We were discussing about ratio test and road test, right? So we finished discussing about ratio test and road test, and before that we did limit comparison test and zero infinity test. Okay. So any questions about those tests, road test or ratio test or zero infinity test? I think road test and ratio test are two series that can be easily applied, right? Because you need to take the ratio and you have to evaluate the limit when k tends to infinity, and you need to determine whether you are getting something less than 1 or greater than 1. Okay. Right. So today we are going to discuss about alternating series and absolutely convergent. Alternating series. Okay. So what is an alternating series? So until now, we were dealing about series that involves positive terms, right? All the series that we did and all the tests that we discussed are for the series that involves positive terms, right? So, but geometric series, it's okay to have negative terms, and for divergence test also, it is okay to have negative terms, okay? Because divergence test says that if you have a series like sigma k goes from 1 to infinity ak, that is a series, and when k tends to infinity, ak is not equal to 0, then series diverges, right? That's what divergence test says, right? So, but for most of the tests, for example, road test, ratio test, both of them needed the fact that AK should be positive, okay? But let's see what is alternating series is. So, alternating series is a series that is in this form. I goes from 1 to infinity, negative 1 to the power k, ak, or summation k goes from 1 to infinity, negative 1 to the power k plus 1, ak. If you have these two kind of series, then we say these are alternating series, right? So this is the reason, right? First consider this one. So summation from here, ik, right? Summation k goes from 1 to infinity, negative 1 to the power k, ak. Suppose this is a series, and if you expand this, what would you get? If k is 1, you would get negative ak, a1, okay? If k equals to 1, you would get negative a1. And if you put k equals 2, then you would get negative 1 to the power 2 would become 1. And then you would get a2. And if k is equal to 3, then you would get negative a3, positive. And the next term is again negative, like that. It would continue, right? So this pattern would continue. Negative, positive, right? That is the pattern. Okay. If you consider this one, the second one that I mentioned, sigma k goes from 1 to infinity, negative 1 to the power k plus 1, ak, right? If you substitute k equals 1, you would get negative 1 to the power 2, that is 1. So you would get a1, negative a2, a3, like that. You continue that, right? Okay. So based on the power, that would determine you are going to start from a negative term or positive term, right? Okay, and in this case, AK is positive, right? AK is positive, and then if you multiply that by negative 1 to the power k, according to the power, you would get some negative term or a positive term, okay? All right, so if I give you some examples, suppose you have some series like this, 1 to infinity, negative 1 to the power k divided by k, okay? What can you say about this series? If you put k equals 1, you would get negative 1 divided by 1. And if you put k equals to 2, you would get 1 divided by 2, negative 1 over 3. positive 1 over 4, like that, it would continue. Okay, right. Next, we will move into alternating series test. Right now, we know what is an alternating series is. Next, we'll discuss what is alternating series test. Alternating series test. Okay. Right. Suppose you have an alternating series. Right. Suppose we have an alternating series. Okay. I will write that alternating series in this summation. K goes from 1 to infinity, negative 1 to the power k, ak. Okay. We know that in alternating series, this guy is positive. AK is positive. Okay. Right. This is what alternating series says. Uh, have alternating series and it should satisfy two conditions. Okay. The first condition is we have an alternating series. Suppose that AK, the sequence AK is decreasing, and the sequence AK is decreasing, and its limit is 0. K tends to infinity, AK is equal to 0. Okay. Right. These are two conditions. The sequence is a decreasing sequence and limit of the sequence is 0. Right. This is the necessary condition, right? Because this should have happened. Okay. Because if this is not equal to 0, then series diverges. Okay. Right. Decreasing and this limit is 0, then alternating series converges. Okay. This is a strong test that we can apply for alternating series. Okay. Because if you have a series that consists only positive terms, then this is not going to be valid. Okay. Next, I would give you an example. Consider the series given by summation k goes from 1 to infinity, negative 1 to the power k divided by k. Okay. Suppose this is your series. Right. Now, what can you say about AK here? AK is 1 over k. Okay. Because I have negative 1 to the power k and 1 over k. Right. Okay. Now, AK is 1 over k. Right. Okay. Now, what can you say about AK? We need to consider these two cases, right? AK should be a decreasing sequence and the limit of AK should be 0, right? So what can you say about limit of AK and is it a increasing or decreasing sequence? Decreasing. It's decreasing. It is clear, right? Because when K is getting bigger and bigger, it gets decreased. Okay. And what can you say about its limit? So AK is decreasing. Decreasing and its limit. That means when limit k goes to infinity, ak is equal to 0, right? It is also clear because when k is getting bigger and bigger, I would approach to 0. Okay. Now, those two conditions are satisfied, right? It's a decreasing sequence and limit is 0. So from the alternating series test, what can you say about this alternating series? It converges, right? So series summation, k goes from 1 to infinity, that is 1 k divided by k, convergence from alternating series test. Okay. So if you have an alternating series, it is kind of easy to test its convergence or divergence, right? Because you need to worry about this limit, right? But if it is not an alternating series, you cannot apply this. For example, suppose I am going to remove this negative 1 to the power k, right? Then you have summation k goes from 1 to infinity 1 over k, right? So then it is difficult to apply for that, the alternating series. You cannot apply alternating series, right? So then you can use P series to determine that it is going to diverge. Okay, right. So let's discuss some more examples. Right. My second example is this. Suppose we have the summation k goes from 1 to infinity, negative 1 to the power k, 3k divided by 4k minus 1. What can you say about this series? What can you say about this one? It is clear that it diverges, right? Because if you consider the numerator, its power is 1, and in the denominator also its power is 1, right? So there's no dominant power in the denominator, right? So in this case, we can see that limit k tends to infinity, negative 1 to the power k, 3k divided by 4k minus 1 is not equal to 0. Okay. You would get negative 3 over 4 or 3 over 4, that depends on k, right? This is not equal to 0, right? Because if you have k to the power 2 here, then it's okay, right? Then you would go to 0. Okay. So the series diverges from divergence test. Okay. Right. So let's move into third example. example number 2 and this is example number 3. Summation k goes from 1 to infinity, negative 1 to the power k, k to the power 2 divided by 3 times k to the power 3 minus 2. K to the power 3 plus 4. Okay. So what can you say about this one? What would happen to its limits? So let's substitute some values, right? So actually, this is the most important part for us, right? Because this is just the thing that alternates the sign, right? So let's check about this. If you put k equals 1, what would you get? 1 divided by 7. And if you put k equals 2, you would get 4 divided by 8 plus 4 is 12. It's kind of increasing, right? Let's see. But when k is getting bigger and bigger, it starts to decrease. Okay. So suppose k equals 3, then what would you get? 9 divided by 3 to the power 3 is 27, multiplied by 3 is 81, plus 4 is 85. Okay. What would happen if you substitute 4? You would get 16 in the numerator, and you would get 4 to the power 3 is 64, 64 multiplied by 3. 64 multiplied by 3. 192, 196. Now can you see something? It's going to decrease, right? So if you substitute k equals 3, you would get, this is 4, right? 5, 25. But now denominator is getting very big, right? Because you get 5 to the power 3, right? So, yeah. 5 to the power 3 is 125, multiplied by 3 is 250, 700, 375, 379. Okay, like that, it would continue. So now you can see the pattern, right? So this AK is going to decrease when K is getting bigger and bigger. And also it's clear that this limit, what is the limit of this guy? 0, right? Because now denominator has the power of 3 and numerator has the power of 2, right? So the most powerful term is the denominator, right? So as a result, that would tend to infinity very fast. So limit k tends to infinity, AK is this guy, that is k to the power 2 divided by 3, k to the power 3 plus 4, that is equal to 0. Okay, so what can you see? This is a decreasing sequence, and if you consider AK, it is decreasing and its limit is 0, so series converges. Converges by alternating series test. Okay. Right. Yes. We will move to discuss about absolutely convergent, right? So if you have an alternating series, then you can apply this test, right? But you have to be very careful about those two scenarios, right? To apply the alternating series test, your sequence has to decrease, right? It should be a decreasing sequence. And if you consider the limit when k tends to infinity, that should be 0, right? Those two conditions should be satisfied. Okay. Right. So there are some instances we cannot directly apply alternating series test, right? So there's a nice definition about absolutely convergent. Right? Absolutely convergent. This is what we are going to do here, right? So instead of considering alternating series, okay, we are going to consider its absolute value, right? So if you are considering absolute value, that means your terms are positive, right? Absolute value means your terms are positive. Then you can apply all the tests that you learned up to 8.5, right? So that is the advantage of this discussion, okay? And it need not to be an alternating series, right? So let's consider some series, right? Suppose you have any infinite series. Suppose summation k goes from 1 to infinity, ak is an infinite series. Okay. Now I have not stated anything about ak, right? So I think you might remember in the ratio test and root test, we discussed that ak should be positive. And I think in integral test also, we discussed the fact that ak is positive. Okay. Limit comparison test also, right? The terms of our series should be positive. But in this case, this is an any infinite series, right? So this can be alternating series also, right? Because AKs are negative, right? Because you can see that alternating series consists of positive and all positive and negative terms, right? If you get negative one, positive one, negative one, now 3 like, right? So AK can be positive or negative or 0, right? Okay. An infinite series. And this is what you have to do. And instead of considering this series, we are going to consider the series derived from its absolute values. Okay? Right. Now, absolute values are positive, right? So now for test the convergence of this series, you can apply any test that you learn. Okay? Now this is a series that consists of positive terms. So you can apply all the tests that you learned in previous classes, right? Now suppose if this series converges, then our original series converges. The converse is not true, right? If the absolute, if the series that I constructed by using absolute value is going to converge, then the original series converges. And we give a special name for this convergence. Then we say that our original series, that is sigma k goes from 1 to infinity ak, converges absolutely. Converges absolutely. Okay. That's the terminology, right? But the idea is this. You are going to consider the series that consists of absolute values of your terms, and you check the convergence of that. If it is converges, then your original series converges. That is the idea. Okay. But what can you say about this would diverge? You cannot say anything, right? If this diverges, you cannot state anything about your original series. Okay. So that's why I mentioned that converse is not true. Right. This is not if and only if case. If this holds, then this is going to be false. Right? Converse is not true. Right? That means this statement implies this statement, but this statement does not imply this. Okay. Okay. Any questions about this definition? Let's discuss some examples. My first example. Summation k goes from 1 to infinity. Cosine k divided by k to the power. Alright. Now you can see that some terms are going to be negative and some terms are going to be positive because cosine k is varying in between -1 and 1. Okay. So now my term, I would get positive terms as well as negative terms. Right? Okay. And also this is not divergence. I cannot directly say that, but I cannot apply divergence test, right? Because this limit is 0, right? Because in the denominator you have k to the power 2, right? When k is getting bigger and bigger, this guy would go to 0, right? So you cannot apply divergence test. Okay. But still, I do not know whether this is going to converge or diverge. Okay. Right. So what can we do? Let's use this test. Okay. Right. Now you have cosine k divided by k to the power 2. Now what we have to do, instead of original series, let's consider the series that consists of absolute values of terms. Right. So let's consider this k goes from 1 to infinity. Absolute values. Okay. Now this is positive, right? Because we have absolute value, this guy is positive, right? Now we can apply any tests that we know. Okay. Right. And now think about this problem. What is the test that you can apply to determine the convergence of this series? It's difficult to apply ratio and root, right? It's clear. Because we have no idea about what is cosine k plus 1 and cosine k. It's difficult to relate them. Let's compare this guy. Cosine k divided by k to the power 2. And I know that cosine k, absolute, this is equal to cosine k, and absolute value of k to the power 2 is k to the power 2, right? Because it's positive. Now, cosine k is varying between -1 to 1, right? So what can you say about its absolute value? It is less than 1. Okay? Less than or equal to 1? Is that clear? Because if you sketch the cosine k, graph of cosine k, in between -1 and 1 and -1. Okay. So its absolute value or magnitude is less than. Okay. Right. Now you have a nice guy to compare, right? So now we know that cosine k divided by k to the power 2 is less than or equal to 1 divided by k to the power 2. Okay. Right. Now what can you say about this series? What can you say about this series? From the P series, it converges. Okay. So you consider the summation from k goes from 1 to infinity, 1 over k to the power 2. Because now the power is greater than 1. So this converges because it is P series. Okay. Right. Then what can you say about this one? Larger one converges. So what can you say about this one? It should converge. So the summation k goes from 1 to infinity. Cosine k divided by k to the power 2 converges. By direct comparison test. Okay, direct comparison test. Right. Now we know that the series that consists of these absolute values is going to converge, right? So then recall this statement. If the series that consists of these absolute values is going to converge, then original series converges, right? So what can you say about original series now? It converges. So summation k goes from 1 to infinity for sine k divided by k to the power 2 converges. Okay. Any questions about that example? Any questions? I think this section is not very hard, right? Because we are not dealing with anything new, right? We are using some tools from previous sections. Right. But the problem is, there are some alternative series that are not absolutely convergent. Okay, I can give you some. My next example. Suppose you have some series like this. K goes from 1 to infinity. -1 to the power k divided by k. I think in one of our previous examples, we know that this series converges, right? So my question is this an absolutely convergent series? Right? So we discussed about absolutely convergent. My problem is this series absolutely convergent? Absolutely convergent. This series absolutely convergent. No. Right. So what is the reason? If you consider the absolute value, so what is the absolute value of this guy? When you're taking the absolute value, that -1 disappears, right? So what is the absolute? Absolute value. K is always positive, so its absolute value is k, and this guy would disappear, so I would get 1 over k. Okay, what can you say about this one? It diverges from P series, right? This diverges. So can I come to this conclusion now? No, right? Because now the series that consists of absolute values is going to diverge, right? It is not going to converge. So I cannot say anything about the convergence of this one from this. Okay, right. So we say that this series is not absolutely convergent. Not absolutely convergent. Okay. I hope everyone can see it. If I write here, can you all see these lines? Okay, now is that clear? Any questions about that statement? Because I evaluated this series and so it diverged, so it is not absolutely convergent. But previously we discussed that this series converges, right? So now this would give you a good information about another important fact, right? So that is, there are some series that are not absolutely convergent, but they converge, right? But we saw that this converges, right? So I will state that. But we saw that the series defined by the summation k goes from 1 to infinity, negative 1 to the power k divided by k converges by alternating series test. So what is the conclusion? Conclusion is there are some series that are not absolutely convergent, but they converge. Okay? So what is the conclusion from this example? Conclusion is there are infinite series, that are not absolutely convergent. Not absolutely convergent. Convergent. But they are convergent, right? Not absolutely convergent, but they are convergent. Or they converge. Okay. So we call this type of series as conditional convergence, right? This convergence is called as conditional convergence. Okay. So that is another definition. So conditional convergence is, suppose it is given that you have an infinite series and it converges conditionally. That means it is not absolutely convergent, but it converges, right? Conditionally convergence is the idea is you have infinite series K converges, but it does not converge absolutely. It does not converge absolutely. Okay. Then we say our series converges conditionally. Okay. The absolutely convergence is very strong condition, right? Because if we can show a given series is absolutely convergent, then you do not need to worry it anymore, right? Because then we know our original series converge. But the problem arises when our series is not absolutely convergent. Okay. Right. So let's discuss more examples. My next example is summation. It was from 1 to infinity 2 to the power k divided by factorial k. Okay, I can give you a hint. Hint is factorial k is more powerful than 2 to the power k. I forgot negative 1 to the power k. Okay. So this fact implies that this series, or I cannot apply divergence test, right? This because factorial k is more powerful than 2 to the power k. That means when k is getting bigger and bigger, this guy would go to 0, right? So I cannot apply the divergence test to say it diverges. Okay. So still I do not know whether it is going to converge or diverge. So can you check for the absolutely convergence? First problem is this absolutely convergent? Is this converges absolutely? Question is, does this converge absolutely? That is my problem. Okay. Can you take some time and try this problem? Consider the series generated by absolute values of these terms. Okay. Any answers? Does it converge absolutely? Yes. You have to consider the series generated by absolute value. So let's consider this one. If the absolute value of 2 to the power k, negative 1 to the power k divided by factorial k. Okay. Now when you are taking absolute value, this negative 1 disappears. Okay. So you would get 2 to the power k divided by factorial k. Now this is a new series, right? So what is the idea? We need to determine whether this one is going to converge or not, right? So now we have a series that consists of positive terms, right? So how do you determine the convergence or divergence of this series? Can you propose a test? Suitable test. When you see factorial k, what can you use? Ratio test, right? When if you see factorial k or some powers like this, use ratio test. That is going to work. Okay. Now this is the series. Now I use ratio test. Okay. So what is AK? AK is equal to 2 to the power k divided by factorial k. And AK plus 1 is equal to 2 to the power k plus 1 divided by factorial k plus 1. Okay. Right. We'll evaluate this limit. Limit k tends to infinity. AK plus 1 divided by AK is equal to k goes to infinity. AK plus 1. That is 2 to the power k plus 1 divided by k plus 1 factorial. We have to divide by this. Okay. Right. Now we have to simplify this. What would you get? Limit k tends to infinity. 2 to the power k plus 1 divided by factorial k plus 1. Here you would get factorial k divided by 2 to the power k. Okay. If you divide 2 to the power k plus 1 by 2 to the power k, you would get is equal to limit k goes to infinity. If you divide 2 to the power k by if you divide 2 to the power k plus 1 by 2 to the power k, that would give you 2, right? So what would you get from here? If you divide factorial k by factorial k plus 1, what would you get? K plus 1 in the denominator. Now what can you say about this one? Limit is 0, right? Because denominator is getting bigger and bigger when k tends to infinity. As a result of that, I would get 0. Okay. And this less than 1. Okay. So from the ratio test, we can conclude that this series converges.
Yes, well, I think we're all on the same page.
Okay. So
Yeah.
it goes from 1 to infinity. 2 to the power k divided by factorial k converges from ratio test.
Oh. Yeah.
Okay, right. Now again, we saw that the series that consists of absolute values is going to converge. Okay, so what is your conclusion about the original series? That should converge. Okay, right. So as a result, original series, it goes from 1 to infinity, negative 1 to the power k power k divided by factorial k. And this converts absolutely, okay? That is the terminology, right? Okay. Because we use the concept of absolute value to determine its convergence, we say that the series converges absolutely. Okay, right. Any questions about that example? Is that clear? Now, did you see the difference between absolutely convergence and conditionally convergent? Right. So if a series is absolutely convergent, then it is a powerful thing, right? Then we can directly say that this series converges. Okay. Now the problem is if there is if the convergence is not absolute, then we have to use alternating series test. Okay. Right. So let's look at another example. Before that, what would happen if I switch them? So now we have 2 to the power k divided by factorial k. Suppose we have factorial k divided by 2 to the power. Then what would happen? Then the series diverges. Because you have factorial k in the numerator, then it's powerful than 2 to the power k. So then it diverges, right?
Yeah. Don't wanna look at it. Screw it, finish it.
Next example is summation. K goes from 1 to infinity. Negative 1 to the power k plus 1. E to the power 2 divided by e to the power. And you try to figure this out. So again, the problem is
That's probably.
that this converge absolutely. Okay. That is my problem. Again, try ratio test. Right?
What word did you bring?
Oh,
Nice.
Any guesses about its absolute convergence? Yeah. Then you have to evaluate the limit and you would one over that. Because when k goes to infinity, you have k plus 1 to the power 2 and k to the power 2. If k tends to infinity, this ratio would go to 1. I'll show that. Because here you have k plus 1 to the power 2. If you expand that, you would get k square plus 2k plus 1. Here you have k square, right? So in both numerator and denominator, you have k to the power 2. So you would get. So you would get 1 over e and it is less than 1. Consider the absolute values. When you are considering the absolute value, there would not be any effect from this negative 1 to the power k, right? Because its absolute value is 1. Okay. Now, again, this is a kind of series that we discussed. Okay. Now, all the terms are positive in this series, then we have to determine the convergence or divergence of this series. Okay. Right. So let's apply the ratio test. Let's apply the ratio test. Okay. AK is going to be e to the power 2 divided by e to the power k. K plus 1 is going to be k plus 1 to the power 2 divided by e to the power k plus 1. Okay, now we have to consider the ratio and its limit. So I need limit when k goes to infinity, ak plus 1 divided by ak is equal to the limit k goes to infinity, ak plus 1, that is k plus 1 to the power 2 divided by e to the power k plus 1 divided by e to the power 2 divided by e to the power k. Okay. So this is equal to limit k tends to infinity. If you divide these two guys, you would get k plus 1 to the power 2 divided by k to the power 2 and e to the power k divided by e to the power k plus 1. Okay. Right, now what can you say about this limit? You can simplify these two guys, okay? Then you would get k plus 1 to the power 2 divided by k to the power 2. You would get 1 over e, right? Because you have e to the power k here, so e to the power k and e to the power k multiplied by e to the power 1. These two would get cancelled and I would get 1 over e. Okay. So what now? What can I say about this ratio? When k tends to infinity, this ratio would go to 1 because you have something like this. Limit k goes to infinity. If you expand this, you would get k to the power 2 plus 2k plus 1 divided by k to the power 2 multiplied by 1 over e. Okay? So if you consider your numerator, the highest power is 2, and in the denominator, the highest power is 2, right? So there is no dominating term, numerator or denominator. So limit is going to be the ratio between 1 and 1. Okay? I would get 1 over e. Okay? The value of e is 2.73, like that, right? So as a result, this guy is less than 1. Okay? Right. So now what is the conclusion from the ratio test? Now my limit is less than 1. So this series converges from the ratio test. So it goes from 1 to infinity. E to the power 2 divided by e to the power k converges. Fourth test. Now what can you say about your original series? Series that generated from absolute values is going to converge. So then we can say our original series should converge, right? So it goes from 1 to infinity, negative 1 to the power k plus 1 multiplied by k to the power 2 divided by e to the power k converts absolutely. Okay. Any questions? Any questions about this example? So our conclusion is our given series converges absolutely. Okay. You understand the difference between conditionally convergence and absolutely convergence. Okay. So those are the things that I plan to do on today. And I think Monday is holiday, right? So let's continue on